Hello and welcome. Please take a moment and read this problem and try it on your own. Let's start by reading it together. It says the function h of t. So right away, h, I'm wondering, is this a function about height, h, as a function of t, time? Let's find out. It says h of t equals negative 16 t squared. I curve my t's so I don't confuse it with the plus sign, plus 144. And here it says this represents the height, h of t. So this is going to tell us our height in feet as an object from the ground at t seconds after it's dropped. So it's the height of an object. Another way you can say that is it's the height of an object as a function of time. And we're also told, and this corresponds to this negative value right here, that the height is decreasing over time. The height is decreasing. And if that's not clear, think about what it's saying. It's saying that the item is being dropped. So say we have this item right here and it's being let go. It's going to fall downward, right? Gravity will pull it downward, I suppose. That's the best way to phrase it. So we expect that over time that the height of this object is decreasing. Let's see what the question's asking. A realistic domain for this function is which of the following? Okay, so functions are defined by domains and ranges. Domain, right, and ranges here. So that just means domain is your input, usually x, the variable x, and domain and range is your output based on the domain, the input. Right? So we go from an input to an output. That's the idea. Furthermore, with function notation, we know that the variable that, the domain is always going to be the variable here inside the parentheses, right? So you can see t is being used here. We know that's our domain. Time is our domain then. And then the output, and it's a little confusing because it kind of overlaps here, but this value, in other words, the height is the range here, right? Height as a function of time. In other words, that's a fancy way of saying how much time has passed affects the height of the object we're looking at. So here they're asking for realistic ways of describing a domain, right? In other words, realistic ways of describing the time. In other words, which of these choices could represent actual times? So choice 1 is out because we're not going to probably include negative times. That would be really fun to do that, right? We don't need negative times. That doesn't really work with most time systems. And I'm now wondering if there are negative time systems. That sounds kind of cool. But here we don't have that, right? So this says t is larger than or equal to negative 3 or less than or equal to 3. Well, it doesn't really make sense that t would ever be negative 2 or negative 1. And I guess it's possible to end at 3 seconds because maybe the object hits the ground after 3 seconds, right? But it's going to start at 0 seconds. So this is my object. It's going to fall. It's going to start falling at the beginning when t is 0. So maybe it takes about 3 seconds to get down to the ground or whatever it's hitting. And then, t would be 3 at that location, right? So I guess it's a 3 second. That's possible. And which is why I think choice 2 is the most reasonable so far, because t could be larger than or equal to 0, 0, 1, 2, 3, any increment in between, and then stop at 3 when it hits the ground. That seems reasonable. But let's look at the other two choices just in case. Choice 3 could be reasonable, from 0 to 144. Maybe it falls further, except this notation right here represents the range, right? So that's saying that the height of the object is between 0 and 144 feet, right? That's what h of t is. So we're not looking at the range here. That might be a reasonable choice if we're looking at range, but we're looking at domain. All real numbers? I don't think so. That wouldn't really work. I don't think negatives, again, which are real numbers, really make sense to use here, right? So negative values wouldn't work, and negatives are real numbers. All right, hope this helped.